Okay, so week 2, classification of geometrical figures. We're going to fly through this today because we got a lot to go through. Okay, so the first 3 triangles, we can classify them according to the length of their sides. If they're all equal, then equilateral triangle. If the two of the length is equal, then isosceles. If all the length are different, then it's scaling. And we can also classify the triangles according to the angles. So this one, the first one here, has all the angles to be less than 90 degrees, which means they're all acute angles, so acute angle triangle. Then the second one has one right angle in the triangle, so right angle triangle, and the third one has one obtuse angle. Obtuse angles are angles that are greater than 90 degrees, so obtuse angle triangle. The sum of all the angles in a triangle add up to 180 degrees. Exterior angles. Okay, so now we're going to go to this one, which is what. So look at this diagram here. Exterior angles are angles where 2 of the angles add up to the exterior angle of the third one. Okay. Maybe we can go through that a bit more later. Complementary angles just means that the angles add up to 90 degrees. Supplementary angles mean that they add up to 180 degrees, like in a straight line. So this is a straight line. If I divide the straight line into 2 angles, these 2 angles will add up to 180 degrees. Simple. Vertically opposite angles is if you have 2 straight lines that cross each other, the 2 angles that are opposite each other are equal. This is called vertically opposite angles. So let's say that one's 70 degrees. This will also be 70 degrees. Okay, let's go through some of these names here. Corresponding angles. Okay, you have 2 parallel lines. So here's 2 parallel lines. You have a line that goes right through it. These 2 angles are also equal, and these are called corresponding angles. So let's say that one was 110 degrees. This is also be 110 degrees. And you can think, you can think of this like an F. So let me just rub this out. Some people remember it like an F, like this. 2 parallel lines. These angles are equal, like an F. Next one, alternate angles. You can think of this one like a Z shape. Okay, so 2 parallel lines. These 2 angles are equal. This is called alternate angles. Co-interior angles is like a C. So 2 parallel lines, a line that goes through it, and these 2 angles add up to 180 degrees. They're not equal, they just add up to 180. Okay, so let's go through some of the sets here. Set 3. Okay, so question 1, classify these triangles according to the length of their side. All the sides are different, scaling. 2 sides are the same, isosceles. And all the sides are equal, so equilateral. Classify these triangles according to their angles. So the first one has a right angle in it, so right angle triangle. Second one, all the angles are less than 90 degrees, so acute angle triangle. And the third one, it has one angle that's larger than 90 degrees. That's an obtuse angle, so obtuse angle triangle. Question 3, draw any triangle, measure the length of the sides and the size of the angle. A is the longest side opposite this largest angle. Okay, so what that means is if you have a triangle, let's say that's a triangle there. Let's say we have let's draw another triangle. Long side, short, and another. Okay, we got the side, the length A, B, C. From this picture, you can see that A is the longest side, which means that it is opposite the largest angle. This angle is the largest angle in the triangle. And the shortest side looks like B is the shortest side, which means that B is opposite the smallest angle. So if you have a short side, opposite that will be the small angle. Okay. Now question C says, in any triangle, the longest side is opposite the largest angle and the shortest side is opposite the smallest angle. Okay. Question 4. Measure the sides in each of these triangles. What kind of triangles are they? If you measure these the length of these triangles and the angles, you'll notice that this is an equilateral triangle because all the lengths are the same. So measure the angles in each triangle. What's the side? What sides are they? They'll be 60 degrees. In equilateral triangle, all the angles are 60 degrees. And question C says, in an equilateral triangle, the size of each angle is 60 degrees. Question 5. Use your ruler to draw an acute angle isosceles triangle with equal side of length 3 centimeters. So, an acute angle isosceles triangle. So that will look something like this. Oops, not the best triangle. Let's say that these two sides are equal, and the sides are 3 centimeters. And this is an acute angle. So all the angles in here is less than 90 degrees, which means they're acute. Alright, question 2, part 2, an obtuse angle isosceles triangle with equal sides of 4 centimeters. So, an isosceles obtuse angle. So that will look something like this. This angle will be larger than 90 degrees, and these two sides are equal, and they're 4 centimeters. A right angle isosceles triangle with equal sides of length 3.5 centimeters. So, something like, nope, that didn't go well. There we go. That's a right angle. Let's assume these two lengths are equal. So there you go. It's a right angle isosceles triangle. Oh, and 3.5 centimeters. Measure the angles in each triangle. How many angles are equal? Obviously 2 because isosceles. What are the equal angles in relation to the equal sides in each triangle? Alright, so question C, what that means is that in an isosceles triangle, let's draw that again. Let's assume that these two lengths is equal. So the two angles that are equal is opposite the two equal lengths. So these two angles are equal because they're opposite the two equal lengths there. So question C, where are the equal angles in relation they are opposite? Okay, question 6a. Draw a triangle with a ruler, then measure the angles. Find the sum of the angles in the triangle. When you do that, you'll find the sum to be 180 degrees, always, in a triangle. Okay, now we're going to go through some of these rules. Actually, some of these we just did already. In a triangle, the sum of the angles is 180. Yes, we've done that. In a triangle, the length of each side must be less than the sum of the length of the other two sides. Okay, so this one is not totally accurate. It should be the length of the, not each side, but the largest side. Must be less than the sum of the length of the other two sides. Okay. In any triangle, the longest side, I'm going to explain this in a little bit. In a triangle, the longest side lies opposite the largest angle, and the shortest side lies opposite the smallest angle. Yes, we just did that before, how I mentioned about this triangle here. The longest side is opposite the largest angle. So the longest side is A, it's opposite the largest angle. Okay, in an equilateral triangle, all angles are 60 degrees. Yes, we know that. In an isosceles triangle, the equal sides lie opposite the equal angles. We just did that one just there. So yes. Okay. Now for the second one, I'm going to have to explain this a little bit, so I'm going to rub this out. Let's put this over here. So imagine you have a triangle. Okay, let's say you have his length here. Whoops. Why won't it rub? out. Okay, so let's say this was 7 centimeters and I want to make a triangle. So I connect 2 more lines to it. Okay, whoops. And let's say this was 5 and this was, I don't know, let's say it was 1. Not to scale. Okay, so can this triangle exist? Can we make a triangle using the lengths 5, 1 and 7? No, we can't. Because the longest side is 7. 7 is not equal to 5 plus 1. 7, for this triangle to exist, 7 has to be less than 5 plus, the other 2 sides add together. So this length plus this length must be more than the longest length, which is 7. Okay, so let's so that's the rule to make a triangle. So let's go through question 9. I'll show you more the rule at the bottom through one of the questions. Now let's look at question 9. Name the smallest and largest angle in each of these triangles. Okay, so the longest side is 8, which means the largest angle must be opposite of the 8. So that must be that one there. We'll put it L. And the shortest side is 6. Okay, which means that the smallest angle must be here, S. Okay, longest side is, question B, longest side is 13, which means this has to be the largest angle. Shortest side is 9, therefore this has to be the smallest angle. Question C, longest side is 14, this has to be, then Q, angle Q is the largest angle. Shortest side is 8, which means that the smallest angle is P, right there. Question D, longest side is 16 centimeters, which means opposite of that has to be the largest angle. And 12 is the shortest side, which means that this has to be the smallest angle. Okay. Question 10. Name the shortest and longest side in each of these triangles. Okay, so we're going to do backwards. We look at the largest angle, which is in this case 80 degrees. Largest angle, which means opposite of that has to be the longest side. Smallest angle is 40 degrees, so the opposite of that must be the shortest side. Okay, largest angle, largest side. Shortest angle, shortest side. Shortest angle, I mean smallest angle. Okay, largest angle, 94 degrees, longest side. Smallest angle, shortest side. 76 degrees is the largest angle, which means this has to be the largest side, and 39 is the smallest angle, so this has to be the shortest side. Question 11, find the value of the pronumeral in each of these triangles. Okay, from question 11a, all the angles in this triangle are 60 degrees. 60 degrees means that this is an equilateral triangle, which means all the length of the sides are the same. So therefore P is equal to 8 centimeters. Alright, here you can question B, all of the length are the same, so that means that each of these angles must be the same. K degrees equal to 60, because it's an equilateral triangle. Question 12, name the equal sides in each of these isosceles triangle. Okay, so the rule says that opposite the angles will be the equal sides. So opposite that one and opposite that one, so these sides are equal. Opposite that, so that's equal to that. So these two lengths are equal there. This length is equal to this length. Question C, this length equal to this length. Question D, this length equal to this length. Okay. Question 15, find the value of the pronumeral in each of these. So we know that in a triangle all the angles add up to 180. So 60 plus 70 is 130. 130, then A must be 50. A is equal to 50 degrees. Okay, question B, 15 plus 25 makes 40. That means M has to equal to 140 because 40 plus 140 is 180. W is equal to 50 degrees. Okay, 32 plus 15 is 147. 147. 180 minus 147 is 33, I believe. 33 degrees. C, okay. 90 plus 21 is 111. 111, so that means this will be 69 degrees. Okay, F, 57 plus 49 is, let me see, 57 plus 49 will be 106, so that means T is gonna be 74 degrees. Now we're gonna do question 16, which talks about the exterior angles. What that means is that, okay, it says find the value of x and y in each of these. X, so 60 plus 40 is 100, x has to be 80. And y is, this is a straight line, so y degrees plus x degrees is 180. So 180 minus 80, this will give you 100. Y is equal to 100. Here you go. 70 plus 50 is equal to 120. 180 minus 120, this has to be 60. Okay, so if this is 60, here's a straight line. 60 plus y is equal to 180 because it's a straight line angle. Okay. So that means that 180 minus 60, this will be 120. Last one, 15 plus 25 gives you 40, so this must be 140. And this has to be 40. Okay, do you notice that these two add up to this one? These two add up to this one. And 15 and 25 gives you the exterior. These are called exterior angles. So question B says, is there a way to find y without finding x first? Yes, there is. The angle marked y are called exterior angles. Copy and complete this statement. The exterior angle of a triangle is equal to the sum of the two interior angles. So let's use that exterior angle and solve question 17. So A is the exterior angle, so A is equal to 70 plus 60 equal to 130 degrees. N is equal to 30 plus 15, which gives you 45 degrees. W is equal to 90 plus 25, which gives you 115 degrees. E, okay, so E plus 40 is 100. E degrees plus 40 degrees equal to 100. So therefore, E degrees equal to 100 minus 40, which gives you 60. E equals 60 degrees. 60 plus T is equal to 100, so 110. 110 minus 60, they'll give you T equals to 50. Okay, so 20 plus y is 65, so y is equal to 65 minus 20, and that will give me 45 degrees. This is an equilateral triangle, so all the sides are equal, so that's 60 and that's 60. 60 plus 60 will give you h, so h is equal to 120. This is an isosceles triangle, so this has to be 80 degrees. 80 plus 80, S is equal to 160 degrees. And this is R degrees. R degrees plus R degrees is equal to 60. So 2 times R degrees equal to 60. R degrees equal to 30 degrees. Can a triangle exist with the following angles? So all you gotta do is just add these angles up. If they add to 180, then yes. The first one is yes, because they add to 180. You can do the rest by yourself. I'm not going to do that one. Which of the following triangles could not possibly exist? So look at this one. The longest length is 8 units. So, and then you have to say, okay, is the other two length 2 plus 5, is it more than 8? 2 plus 5 is 7. 7 is less than 8, so no, this cannot exist. Longest side is 6 centimeters. Is the other two side 4 plus 5 more than 6? 4 plus 5 is 9. 9 is greater than 6, which means yes, this can exist. Longest side is 11. 9 plus 6, oh sorry, not 11. It looks like it was, but this is the longest side. 16. Is 16 less than 9 plus 11? 9 plus 11 is 20. 20 is more than 16, so yes. This is the longest side is 7. 7 is 7 more than 3 plus 4? So this is 7 equals 7. 3 plus 4 is 7. 7 equals 7, so no. It has to be more. It cannot even be equal to. Okay? So what I'm trying to say is the longest side here has to be less than the sum of these of the other two lengths. So 6 plus 10 is 16. 16 is more than 15, then yes. 7 is so 7 is less than 3 plus 3, so therefore no. Okay. What are we at? Is it possible for a right angle triangle to have an obtuse angle? So right angle triangle always has one right angle and the other two has to be acute, so no. Just going to put a cross there. A triangle to have two right angles? No, because two right angles add up to 180 degrees already, and you need three angles to add up to 180. So that means that three angles will add up to more than 180, which doesn't make sense. A triangle to be both right angle and isosceles. Right angle and isosceles. So it looks something like this. Yes, it can. Is right angle triangle. So this and yes. An equilateral triangle to contain an obtuse angle. Equilateral triangle has all the sides, all the angles to be 60, so no. They can't be, none of the angles can be obtuse. A triangle to have two obtuse angles. No, you can't. Obtuse means that they're both larger than 90 degrees, so the sum of the triangle will be more than 180. No. A scalene triangle to be right angle. Yes, you can have a scalene triangle that's a right angle, like this. Oops. So that's yes. G, an obtuse angle triangle to be isosceles. Yes. Like this. So this is obtuse angle, and imagine this is isosceles. So that will be yes. H, a triangle to be both equilateral and right angle. Equilateral and right angle, no. Equilateral contains all the angles to be 60, so there's no 90 degrees angle in there. A scalene triangle to have an obtuse angle. Yes, you can. So that's obtuse angle, and this is all the sides of different size. Okay, the rest of them you can do by yourself. This is set 4 for homework. So, okay. Hope that helps.